What's an easy way to seek data for machine learning? Machine learning is hot now. For machines to learn to do useful things, we need to train it with data. Let's take this example. Sam is ready to buy a house, so he fills out an application for a home loan. The bank collects information from Sam, like his bank balance, his credit history, his monthly income, his age, his address, his assets, and so on. This information is fed into a computer that runs it against a bunch of pre-programmed rules and approves or denies Sam's loan. These rules have been coded into the computer by programmers who have extracted that knowledge from experienced loan officers. The loan officers could make a pretty good guess on whether the loan will be repaid or not. The problem was that these rules had to be maintained in the computer. Say the unemployment rate increased, then the chances of default would be higher. Then the dependency among rules matter. Maybe the bank has to increase the income limit, but then if the customer has enough assets, perhaps the income doesn't matter. Perhaps the default rate depends on the loan amount, and these rules apply only to smaller amounts. Things can get really complicated pretty quickly with such interdependencies, and rules are hard to maintain. So instead, we use machine learning to approve or deny loans. To do that, we would feed the machine lots of historical data about customers who took loans, including information about who paid it back and who didn't. With this data, machine learning algorithms can identify the underlying patterns in the data and figure out which attributes really matter in figuring out which customers are likely to pay back the loan. Perhaps the single most important factor in loan repayment does not depend on the person's income, but rather on her education level. In this video, I won't discuss machine learning algorithms. I'll just focus on the data. So what does this data look like? It is rather simple. All machine learning algorithms work with data that's tabular. Each row represents one data point, and the columns show the characteristics. In this loan example, the customer information is organized as rows and columns. This means there's no complex relational or hierarchical structures. This simple structure helps you to think about what data you'd need and how to collect it, because this is the way it is fed into the machine learning algorithms. We'll also assume that all values are numbers. If they are not, we can easily map them to be. Each row is a single data point that can be plotted on a numerical axis. Each column is one of the axes. So if you have two columns, each row can be plotted in 2 dimensions. If you have 3 columns, each row can be plotted in 3 dimensions. After 3 dimensions, visualizing the data gets difficult, but you can imagine that each row is a point in multidimensional space. All the machine learning algorithm does is identify patterns with this data. Here's one example of what that might look like. The green marks customers who have paid back the loan, and the red marks customers who have not. If this is the underlying pattern, then the machine will reject loans for people who have low income and a low education. By the way, this example is fake and is for illustrative purposes only. Data is important for machine learning, but you can think of the required data as a simple table. Now that you know how the data is organized, all you have to figure out is how to go and get it. A note here that data for deep learning requires a slightly different approach. Perhaps I'll cover that in another video. Thanks for watching.